All right, so when we have problems like this warm-up, the common denominator, that's really nice. We want the same denominator in order to add these things together. So for example, the first one, 2/5 plus 4/5, because they have the same denominator, we could technically rewrite that as we're just adding the numerators together. The denominator just stays the same. So it's really like 2 plus 4 over 5. So this would really just be 6/5. All right. The second one, 1/3 minus 1/3. 1/3 minus 1/3 is going to be basically like 1 minus 1 over 3, or just 0/3, or just 0. That's what it would simplify to. Okay. 1/3 minus 5/3, it's like 1 minus 5 over 3. Again, common denominator means we can just put the whole thing together, and we're just looking at just adding or subtracting the numerators. So that becomes -4/3. Okay. Now numbers 4, 5, and 6, I have different denominators here. So I have 1/2 plus 2/3. So I cannot just add 1/2 and 2/3 together. What I have to do is I have to find the common denominator here. So for example, I could say let's multiply the left equation by 1, but I'm going to multiply it by 3 over 3. And I chose 3 over 3 because I have a denominator of 3 on the right side. And that's where I got the 3 over 3 from. On the other side, I have I'm going to multiply by, let's see, 2 over 2. And that's multiplying by 2/3. And I got that 2 over 2 because the denominator was 2. And what happens is when I multiply straight across for everything. So I have like 3 over 3 times 1/2, that becomes 3 over 6. And think about 3 over 6, that's the same as 1/2. So we've just rewritten this as a fraction that's the exact same. And then if we multiply 2 over 2 times 2 over 3, we end up getting 4 over 6. And we'll see the exact same thing. I have 4 over 6, that's the exact same thing as 2/3. It's just like an unsimplified version of the fraction. And that's how I find my common denominators. And now I have 3/6 plus 4/6. Well, that's 3 plus 4 over 6. So this simplifies to 7 over 6. And I can just leave it as an improper fraction. I do not need to change it to a mixed number or anything like that. All right. So I basically want to look for whatever the smallest multiple is of both numbers. So 2 and 3, the least common multiple was going to be 6. All right. So I could do that a little bit faster. Now I look at this one, 5 and 3. What's the least common multiple of 5 and 3? It's going to be 15. That's another way to look at it. Or I get this thing about 9/5 times 3/3 minus 4/3 times 5/5. All right, multiplying by that denominator. That'll work every single time if you multiply by the denominator the other side. But sometimes we might not find the least common multiple. We might find one bigger, and we might have to simplify the fraction at the end. So it could be an extra step if we do that. But in this case, it's going to work. I'm going to get 27 over 15 minus 4 times 5 is 20 over 15. So I get 27 over 15 minus 20 over 15. That's going to be 7 over 15. 27 minus 20 is 7. And that's what number 5 is going to look like. All right, last one, 9/5 minus 5/8. This one looks like I'm going to have to multiply by some big numbers, like 8 over 8, and then 5/8 times 5 over 5. And I'm going to end up getting something like 72 over 40 minus 25 over 40. All right. And now I would just say, okay, well, I'm going to have a common denominator of 40. 72 minus 25 is 47. So I get 47 over 40. That's how I get the last problem there. So when we're adding and subtracting rational expressions, that's the plan for today. Let's say today's period 1, November 30th, last day of November. November always goes so fast. Man, just because we have no school in November, we had that nice long Thanksgiving break. That was great. Okay, so it says describe the process for adding numeric fractions. So what we just did on the problems 1 through 6. So the first thing we did was we said let's create a common denominator. That was the first step. We didn't have to do that on problems 1, 2, and 3. It already had a common denominator. The second step was add or subtract the numerators. All right, and we kept the denominator the same. Keep the common denominator that we just found. And then finally, the third step is just going to be simplify if needed, which we didn't need to do on any of these first few problems. But like I was saying, if you find the common denominator and it's not a least common multiple, then you, or the least common denominator, then you will need to simplify a little bit. But we'll talk about finding the least common denominator here in a second. So what we do to find the least common denominator, which we didn't, like I said, we didn't do that on the warm-up, but we're going to factor each denominator. I'll show you how to do this with rational expressions. And then we're going to make a list of all the common factors shared by each denominator. And then we're only going to write one instance of each factor together in a single expression. So I'll explain what that looks like here. Okay. So for these first couple examples here, it says 1 over 3x squared and 1 over 6x squared minus 3x. All we're doing is we're finding the least common denominator. Okay, and we're going to add them together. Okay, add together by finding the least common denominator. So this first example, I'm going to start by writing 3x squared is 3 times x times x. Just going to expand it. The second denominator I'm going to write as, I got to factor it. So it looks like I have a common factor of x in both terms and a common factor of 3 in both terms. So I'm going to pull out a 3x. And then I'm going to be left with a 2x minus 1. All right, so I have to be able to factor both of these. Now I want to write down my least common denominator. So what we want to do is we want to start by saying, what do both denominators have in common? Well, they both have a 3, and they both have an x. So that's the first part. They both have a 3x. Now, what's the left side have that the right side doesn't? Well, the left side has another x. So we're going to put another x up there. And finally, what's the right side have that the left side doesn't? The right side has a 2x minus 1. So we're going to put a 2x minus 1 up here. So just to recap, we have what was on both sides in blue. In our green, we have what was just on the left side. And in yellow, we have just what was on the right side only. That's how we'd find our least common denominator. And I'm doing that in different colors because the next step, what we're going to do is we're going to write our expression 1 over 3xx. And we're going to have to multiply that left side by the value that was on the right side only, which was 2x minus 1 over 2x minus 1. And then we're going to do the same thing with the right side. 1 over 3x times 2x minus 1 times x over x, what was on the left side only. And we're just trying to create that least common denominator. We want all of our denominators to look like this. 3xx times 2x minus 1. And on the left side, we'll see that we have a 2x minus 1 times 1, so that just becomes 2x minus 1 over 3xx times 2x minus 1. That's perfect. And on the right side, we're going to see 1 times x, that's x times 3xx times 2x minus 1. Okay, now we have that common denominator. Okay, so now the last step is to go ahead and add the numerators. Well, we have 2x minus 1 plus x plus 1x. So that really just becomes 3x minus 1. And then we have over 3x squared times 2x minus 1. I'm just going to rewrite it as 3x squared times 2x minus 1 for right now. Okay. And there's nothing that can be simplified out. We have a 3x minus 1, and we have a quantity 2x minus 1 below it. So we can't really simplify anything, but we want to check. That's the last step, simplify if needed. But that's it for this problem. We've got that as simplified as possible. We could multiply the 3x squared times 2x and the 3x squared minus 1 times negative 1. And rewrite that denominator in standard form. But I think it's okay to leave the denominator in like more of a factored form. I think that's fine. I definitely want to see numerators in standard form, but the denominator, we can kind of leave in that factored form for now. Okay, so by now, what you've hopefully noticed, simplest these rational expressions get. All right, unfortunately for us. Let's go ahead and look at one more example here. Example B, 1 over x squared minus 4. So I'm going to rewrite that. That's a difference of squares problem. So it's going to be x minus square root of 4 and x plus square root of 4, which just comes out to a 2. X minus 2, x plus 2. Now the second one, x squared plus 5x plus 6. So on that one, let's see, plus 5x plus 6. I'm hoping there's an x plus 2 in this one, just because I want to see that they share something in the denominator. So I'm hoping there's like an x plus 2 here. And if I did that, that would make this an x plus 3. X plus 2 times x plus 3 is positive 6, and I get a positive 3x. A positive 2x, and sure enough, I did get an x plus 2, which is nice because that means I'm going to have a common factor in both parts of the denominator. Now when I'm listing my least common denominator, like I said, there was an x plus 2 that was on both sides. The left side needs to be x minus 2, and the right side needs to be x plus 3. So that's the right side. The left side, both sides. All right, that's what we're looking at here. And now, because I have the x plus 2 on both sides, the nice thing is I don't need to multiply both sides by that. But what I do need to multiply the left side by is by that x plus 3. And then the right side is going to need to be multiplied by the x minus 2. So we'll do the green side. Okay, and that's what our fractions will look like here. The nice thing is, again, the numerator is just 1, so we can literally say 1 times x plus 3, and then we can write out our entire denominator in factored form. X minus 2, x plus 2, x plus 3, and then the other numerator is going to be x minus 2 times x plus 2, x plus 3, x minus 2. And we do want to see, they might be in a different order, but we've got that common denominator. They both have the same 3 factors, which is good. And now we're just adding x plus 3, oops, and I can delete those parentheses there, and x minus 2. So we're really doing like x plus x, that's 2x, 3 minus 2, that's 1. So this whole thing is going to simplify to 2x plus 1 over my denominator, x plus 2, x plus 3, x minus 2. And like I said, I'm not going to ask you guys to go ahead and put that denominator back together when it's in factored form already. From this point forward, we'll leave those denominators. All right, but I would want you to put the numerators back into standard form if possible. But in this case, this numerator is simplified as much as possible. All right, what I'm going to ask you guys to do now on the next 3 practice problems, I'm not going to ask you to do any adding or subtracting. I'm just going to ask you to find the least common denominator or the smallest common multiple of both pairs. So find the LCD. All right. So that's all you need to do for these 3. Find the LCD. So factor the new denominators and then list that least common denominator for me. Okay, so take a couple minutes to work on those 3 problems. Let me know if you have questions on anything. Practice problems. The first one's a little tricky because you'll see an 8 and a 4, but one thing we have to keep in mind is that the least common denominator, 8 could be rewritten technically as 4 times 2. So that means there's a common factor of 4 in both terms. So I could say, hey, there's a 4 on both sides, and then there's a 2 on the left side. And then there's an x plus 3 on the right side. That's how I'd find my least common denominator, and that's all I'm asking you guys to do right now. So 4 times 2 times x plus 3, or 8 times x plus 3 would be your least common denominator if we wanted to combine the 4 and the 2. All right? That's the idea for these practice problems. For problem number 2, it was 1 over 10x. And the other one was 1 over, looks like I have a common factor of 5x on both sides. So I get an x plus 3. And again, I have the same situation where a 10 could be rewritten technically as 5 times 2. So both sides are going to have a 5x. The left side is also going to have a 2, whoops, that the right side did not have. And then the right side is going to have an x plus 3 that the left side did not have. And that would be our least common denominator, 5x times 2 times x plus 3, or you could rewrite it as 10x times x plus 3 if you wanted to combine the 5 and the 2. That's kind of the trick with these problems here. And then the last one, x squared minus x minus 6. All right, I'm just going to start by creating my box method, and I can do a minus 3 and a plus 2 there. positive 2x, negative 3x. That's because we have negative 1x in the middle. So one side is x minus 3, x plus 2. Hopefully the other side also has an x plus 2, and it does when I factor out a 4. So it looks like both sides are going to have an x plus 2. The left side's also going to have an x minus 3, and the right side's going to have a 4. So I can write this as 4 times x plus 2 times x minus 3. There's my least common denominator. Okay? And that's how I would find those values for these types of problems. All right. The first thing we want to do is we want to find the least common denominator, which we just practiced. Of the two fractions. And then we're going to multiply both fractions by the least common multiple over itself. It's the same as multiplying by 1, so we've already seen that a couple times. To force each fraction to have the exact same denominator. All right. And then the last part, we're going to add or subtract. We're going to combine like terms, and we're going to simplify if possible. Those are kind of our 3 steps here. All right. So first example here, example A, says 7 over 12x, and then minus 5 over 12x. This already has, our least common denominator, 12x. That's kind of nice. So in reality, this is just 7 minus 5 over 12x, which is going to be 2 over 12x. And now because it's 2 over 12x, I should be able to see, 2 divided by 12, that needs to simplify a little bit. That can become 1 over 6. So I'm going to get 1 over 6x. That's the simplified expression there. So that's what I mean at the very end, on the last part, after we do the add or subtract, we need to see if we can simplify if possible. Okay, that's what the last part's saying there. All right, part B, we're going to have x plus 2 over, I'm going to pull out a 2, and I'm going to have times x minus 1 on the left side. On the right side, I have negative 2x minus 1. And I can factor that out. X squared minus 4x plus 3. It's going to be x minus 3 and x minus 1. All right. If I need to create the box to do that, I should. I could see it as a plus 3, and both numbers need to be negative, and the only factors of 3 are 3 and 1. So now identify my least common denominator. Both sides are going to have an x minus 1. Left side's going to have a 2. Right side's going to have an x minus 3. So my least common denominator needs to be multiplied by x minus 3 on both sides. My left side does. And my right side, I have this minus 2x minus 1 here over x minus 3, x minus 1. That needs to be multiplied by 2 on both the numerator and denominator. Okay. So now this left side is x plus 2 times x minus 3. Denominator, x minus 1 times x minus 3. And now on this side, I've got negative 2x minus 1 times 2 over 2 times x minus 1 times x minus 3. All right. Now this is where they get a little bit tricky, because I have to put the numerators into standard form in order to combine like terms. So the x plus 2 and the x minus 3, I have to combine that. All right. So that's where these problems get a little trickier, because now I'd have to say this is going to be x squared minus 3x plus 2x minus 6. That's the left side. all over 2 times x minus 1 times x minus 3. The right side, I have this minus, and it's going to be negative 4x minus 2 over 2 times x minus 1 times x minus 3. Now, because this is a negative sign up here, I could actually distribute that negative through to everything. And it's going to become a, we'll simplify now a little bit. X squared, right here, combining my like terms. I had a negative 3x and a positive 2x. That becomes a negative 1x. And on the other side, I distributed the negative. It's going to become a plus 4x plus 2. And that's all over the common denominator. 2 times x minus 1 times x minus 3. And now I'm going to get x squared, and I have common terms, negative x and positive 4x. That's going to be a positive 3x. And then I have a negative 6 and a positive 2. That's going to be a negative 4. So x squared plus 3x minus 4 over 2 times x minus 1 times x minus 3. The last step here is to make sure there aren't any common factors. Nothing else I can simplify. Unfortunately, my numerator is in standard form, so I would want to simplify that again. X squared plus 3x minus 4. That could be a positive 4 and a negative 1. That's a negative 1x, a positive 4x. That'll give me a positive 3x. And that's good because it actually means I do get something that does simplify here. I have an x minus 1 in both the numerator and denominator. So this does simplify a little bit more. And after all that work, a lot of work, we ended up with this. X plus 4 over 2 times x minus 3. I'm going to box that up. So our like terms for this one, 2x plus 2x is 4x. Negative 6 plus 2 is negative 4. And we have x plus 1 times x minus 3. And now I could distribute a 4 out of there, and I'm going to get 4 times x minus 1. And unfortunately, that does not match up to anything on the denominator. Like I have an x plus 1 on the denominator, but not an x minus 1 on the denominator. So I can just leave it in standard form like this on the left side. I can't really do anything with that x minus 1, unfortunately. So I'll just leave it as 4x minus 4. But I did double check to see if I could possibly factor out here, but the x minus 1 and the x plus 1 do not factor. So we're just going to leave it as we did on the left side. Okay. Problem 3, the left side was 2x over x plus 2, and the right side was a difference of squares, so that was 7 over x plus 2 times x minus 2. And that means on the left side, we're only going to have to multiply by x minus 2, x minus 2. And the right side, we don't need to multiply anything because it's already got that least common denominator. So I end up with this 2x times x minus 2. That's going to give me a 2x squared minus 4x. And then it's all over x plus 2, x minus 2. And then I would just have plus 7 there. And then I could look for a least common denominator. And what I'd be hoping for is I'd be hoping that one of these was like x plus 2, which would make this a 2x minus, the only factors of 7 are 7 and 1. So unfortunately I can't get an x plus 2, I can't get an x minus 2. So that's actually not going to simplify at all. So that's as simple as this one's going to get. All right, 2x squared minus 4x plus 7. But we do want to double check and see, can we get an x plus 2 or an x minus 2 to factor out of that? And because of this 7 right here, we cannot. All right. And then the very last problem, x plus 1 over this side became x plus 2 times x plus 2. This side over here became 6 over x plus 2 times x minus 2. So let's see here. My least common denominator, I think I might have messed it up actually. So I have an x plus 2 on both sides. So that's both sides. Then on the left side, I have an x plus 2. So I don't have an x plus 2 up here. So I need to put that up here. So that's why I double check. There should be an x plus 2 up there because of this extra x plus 2 down here. And then on the right side, I have an x minus 2, and that's where this x minus 2 came from. All right. So now I can go ahead and get to work on this one. I need an x minus 2 on this one. And I'm going to write this as x plus 2, x plus 2, x minus 2. So I just put the x minus 2 straight in there. And on this side, I'm going to multiply the numerator and denominator by an x plus 2. So again, I just did the extra x minus 2 over x minus 2. I just included it already. And did the extra x plus 2 and x plus 2, included it already. So now I've got those common denominators. And now I have to distribute. I get an x squared minus 2x plus 1x minus 2. And then on the other side, I'm going to get a 6x minus 6x plus 12 all over x plus 2, x plus 2, x minus 2. Most common mistake students make with these problems is because this is a minus here, they forget to distribute the negative to all of the terms. So this should become a negative 6x minus 12 there. All right, negative 6x minus 12. So as I'm combining like terms, I'm going to get an x squared minus x minus 2, and then minus 6x minus 12. And then I get a negative 6x, that's going to give me a negative 7x. And then negative 2 minus 12 is negative 14. X plus 2, x plus 2, x minus 2. And now, because I see x squared minus 7x minus 14, I do want to double check that numerator. And I want to see if I can get either an x plus 2 or an x minus 2 to factor out of this. So if it's an x plus 2, that means I'm going to need an x minus 7 over here. And right now it looks like that's not going to happen because that would give me a negative 5x in the middle. And I think I did that right. Negative x minus 6x. Yeah, so that's not going to work. And then if I did x minus 2, it would be an x plus 7, and that's not going to work either. So this is as simplified as this expression should get, I think. The x squared minus 7x minus 14. Okay? So that should cover everything for today. Any questions there? All right.